We are pushing along, and we're almost live. Now we're going live. All right. Let's see. The next talk for us is Nikhil. Nikhil, are you around? Can you hear us? Are you?
Hey, Adam. I can hear you. Can you
Nikhil,
hear me?
how you doing, man? Where are you dialing in from?
I'm dialing in from East Bay, Fremont.
From Fremont. Nice. We'll be there in just a few days for another big conference coming up. So, Nikhil, I'm going to clear up the stage and I'm going to step down. I'll be back in 10 minutes to perhaps, if we have some time, with some questions from the audience, but I can't make any promises because this conference is moving along quickly. Nikhil, the floor is yours.
Thank you, Adam. Hello, everyone. Thanks for taking the time today. I'm going to talk to you about Chronon. Chronon is a data platform we built for ML and AI use cases while at Airbnb, also jointly with Stripe. And we open sourced it like last year. So a little bit about me. I'm Nikhil. I was working on ML infra stuff at Airbnb for a long time. Before that, I was doing stream processing related stuff at Facebook. We built our own stream processing engines while there. Before that, I was doing ML infra again back at Amazon and Walmart Labs. So currently, we have founded this company called Zipline AI to help people use Chronon. So what is Chronon? So Chronon is something that serves two main purposes. It turns raw data into training data, and it also helps serve features. And because there is a lot of commonality in how people compute metrics, it also gets used accidentally for generating offline and online metrics. Right. So we have early adoption from a few companies, so contributors, evaluators, and adopters from a bunch of companies. It's been only a year now, so it's like really early adoption from these companies, and we work with few of them to get their deployments into production. So what do people use Chronon for? So the main one is predictive machine learning use cases, so search, indexing and ranking, ads ranking, feed personalization, fraud and abuse, prevention, both monetary and like hate speech and that sort of stuff. And also to personalize marketing material and like to do pricing. So there is a wide variety of use cases. This is what it's traditionally been used for. But in the last 2-3 years, we have seen a growing number of use cases that are like more using LLMs and generative AI. So customer support, which used to be traditionally predictive ML, but now more generative AI oriented. It's also used for creating virtual assistants, both for shopping, travel, etc. It's used for rule engines. So sometimes you don't have enough time to retrain a model when new fraud patterns occur. So in that case, you want people to come up with heuristics. For a day or two, these heuristics run and filter traffic out. And that's where rule engines come into play. You give your heuristic to this rule engine and it filters traffic out. And it's also used in user-facing metrics, like I mentioned. So high traffic landing pages are essentially like listing ratings or item ratings. You can imagine the amount of traffic these pages see is quite high, and you want these ratings to be updated in real time. And just regular offline business metrics like customer 360, listings 360, etc. So why do people use Chronon? So the crux of Chronon's engine is this thing called incrementalization. So to give you a vague intuition of what incrementalization is, like let's say you want to compute average rating of a listing in the last 90 days. You're going to compute it today, and let's say you want to compute it again tomorrow. You have about 89 days worth of overlap. So we are going to aggregate 90 days today and another set of 90 days tomorrow, and there is 89 days that overlap today. So if you can effectively incrementalize this computation, you're going to save about 45x of computation, or like 90x in like extreme cases. So that's the crux of it, and that like makes the Chronon engine scale and generate like training data and serve features at large scale. And it's unified, meaning you write the feature definition once and it creates both training data from that definition and creates an online serving endpoint. And it makes sure that the data that's being served is fresh. So if you have event streams, it incorporates data from the event stream into the endpoints. And it's very pluggable. So you can plug in your event streams with a Kafka, PubSub, or you can plug in your warehouse, which could be on Iceberg, traditional Hive, Hoodie. It could be on Google BigQuery, and we will be able to like pull data from that, transform that into training data and features for serving both. So under the hood, we like built on a bunch of technologies, some open source, some not. We connect to these things and we pull data from these things. And we have Chronon basically implements its incrementalization algorithms over two engines, one for batch processing, which is Apache Spark, another one for stream processing, which is Flink. And it stores online data and indexes them into right now it's an open connector, so anyone can implement any connector to any database, but we have implemented connectors for these three. All right, so how is it related to Zipline? Zipline is just like a bring your own cloud offering of the Chronon platform. We have things that make it production grade, stuff like built-in ML observability and governance. I'm going to talk a bit more about these today. And other things like experiment isolation. So in ML, you want to have a very fast experimentation loop when you come up with new features, and you want to isolate these experiments without affecting production. And the other thing is compute sharing. So a lot of the times these experiments do need to share compute. So we want isolation, but also want to share as much as we can. So I'll talk a bit more about this later as well. And we are integrated with some of the ML platforms that exist out there, like Vertex AI and SageMaker. And we do native embedding generation. That's like the delta between Chronon and Zipline. So about governance, the first thing is compliance. The main questions that get asked here is like which models depend on a given sensitive column. And then there is another aspect of governance, which is lifecycle management, which is what models depend on a given column that I'm about to deprecate or I'm about to change. So if you see, these questions are like awfully similar, and like what is needed to really answer these questions is a global column lineage graph. So which basically says this column's data flows across all of these pipelines and ends up in a model, which goes from the source of the data all the way into the endpoint that is serving the model, regardless of how many stages there are in between. One thing that makes Chronon really effective at doing this is that it's declarative. So there is no black box Python code or Java code that we allow. It's more data frame like in every stage. And because it's data frame like, we can extract the lineage statically. So users don't have to tell us that this is the lineage. We can pull it out from the feature definitions that you already have written. So this is like roughly what gets pulled out. So we have tables and columns in between, and we know how columns are connected and what filters get applied, etc. And like we can create this graph globally across every source of data and across every model. So the other one is observability. So ML observability and AI observability is pretty tricky. It's a large area. I would say much larger than the core of building features and prompts itself. So there are many metrics here. One is prediction drift, which basically measures how have predictions drifted relative to past. Similarly, there is label drift and feature drift. So the point of observing these things is that we know if there is something wrong going on with the model. And then there is feature importance stuff, which determines what's the influence of a given feature on a decision. So if you want to analyze a decision why this model predicted a certain way, this is very useful so that when someone calls and says, hey, I'm done, why is that? So people can look at the model's decision and say, okay, this is probably why. And the other one is model decay. As real world preferences changes of users, labels and predictions no longer like match. And this is what we call model decay. And then there is consistency, which means the difference between training data and serving data. So we need to be measuring all of these to know, and these are all orthogonal. So we need to measure all of this independently to know if a model, if an ML system is healthy or not. So the difficulty here is that there is thousands of features per model, and each feature has a lot of data quality metrics around just one feature. And if you multiply, that's a lot of data quality metrics. And this is usually harder than building the feature pipelines themselves. So most often these things don't get built. So another advantage that Chrome has here is that it's declarative, which means we can derive what needs to be measured and auto-complete these metrics. And we can automate the observability of all of these pipelines. This is roughly what it looks like. You just write your feature definitions and we generate these drift metrics and all these other metrics that I showed you before. Right. And another cool advantage is that we can put lineage and drift side by side and say, hey, this feature is drifting, so let's see what other pipeline is producing this, and then go upstream to see where the drift is originating from, and go talk to the owner of that data. Right. And the other area that I'll quickly cover is experimentation. So we have safety and isolation as a requirement, so we don't want to impact any production data, and we want to reuse all existing data. So what this means is we should read, but we cannot override production. So let's say this is a production set of pipelines, and I want to make a change to one of the nodes, denoted with C. I want to make a change and make a copy of everything downstream and keep the purple ones untouched, and at the same time reuse dependencies from the production. So this is what needs to happen, and this is a very complex orchestration problem, and this is something that the Zipline engine solves for. So recap, Chronon is good for generating ML systems, especially generating training data and feature serving that applications can consume and metrics. And Zipline on top of that adds observability, governance, and experimentation. And things that I didn't talk about are like embeddings and model integration. So if you want to learn more, please join the Slack channel. So you can visit chronon.ai, join the Slack channel, and start using the open source project. If you're interested in a managed offering, you can reach out to us at hello@zipline.ai. Thank you for your time.
Awesome. Nikhil, that was excellent. It felt like we went by really quickly. That reframing slide was sick. I mean, I feel like we could just spend an hour just, zooming into how you guys are actually pulling this off. Does not sound trivial. So, very interesting. All right. Thank you, Nikhil. We have a couple of more talks on this stage before we're going on to the next one. If you haven't yet submitted the survey, I'm going to pull it up. Give me 1 second. I want to make sure that you're all filling out the survey. This is the open data survey. Scan the QR code while you can. This is our way of being able to understand what's happening in the space, what is becoming. We're going to publish this. We're going to get a good sense of how open people's data actually is, and give us a good sense of patterns that are emerging and trends that we're seeing. I'm going to give it away to Jono for one more moment before we kick off the next